You already know what RAG is: chunk, embed, store, retrieve, generate. The question this lesson answers is sharper. What does RAG look like when you wire it with LangChain? And where do real teams diverge from the framework? Here is the core idea, and it is what makes LangChain RAG feel like Lego. LangChain gives you one primitive per stage and they share interfaces so they snap together cleanly. The whole prototype fits on one screen. Let me walk the pipeline in the exact order data flows because that order is the mental model. First beat, the loader. A loader normalizes stuff on disk into LangChain's document, which is just page content plus a metadata dict. You write pipt floater of contract.pdf, call load, and get back a list of documents, one per page, each tagged with source and page number. Do not skip that metadata. It is how you later filter retrieval to one customer's docs and how you cite sources back to users. Second beat, the splitter, because a document per page is almost always too big to embed. RecursiveCharacterTextSplitter is the workhorse. It tries to split on a list of separators in order: paragraph, line, space, falling back as needed. You set chunk size, the single most important RAG knob, and chunk overlap, usually 10 to 20%. So a key sentence is not sliced in half at a boundary. Call split documents and your pages become a longer list of bite-sized chunks. Third beat, embeddings and the vector store in one motion. You make OpenAIEmbeddings, then Chroma.from documents with your chunks and that embedding, and optionally a persist directory. Chroma is the easiest local store. Swap in Qdrant, PageVector or Pinecone for production and the interface barely changes. Fourth beat, the retrieval chain, where it all comes together. Every vector store hands you a retriever via asRetriever, and modern LangChain wires the rest with create-retrieval-chain. You build a documents chain that stuffs retrieved context into a prompt, hand it plus the retriever to create-retrieval-chain, and invoke with your question. Behind that, one call. The retriever fetches the top K chunks. They are formatted into the prompt's context slot, and the model answers grounded in your data. That whole thing, load to split to embed to store to retrieve to generate, is maybe 20 lines with the real classes. Now the part that changes how you debug RAG. Chunking quality matters more than the framework, and a retriever returning top K is not the same as the model having the answer in front of it. If the right chunk is not in the top K, no prompt engineering recovers it. So always measure recollat K separately from answer quality, because most RAG bugs live upstream of the model. Prototype the skeleton in LangChain in an afternoon, then productize deliberately. A smarter splitter, hybrid retrieval, a re-ranker. The skeleton stays, the meat becomes yours, and that is a perfectly good outcome.